Welcome back, guys. This is our lecture on electronic circuits. Let's get started. Previously, we talked about Ohm's law. This was a law that represented the relationship between electrical pressure, the flow of electrons, electrical current, and the electrical resistance that different materials have as electricity goes through them. And Ohm's law in equation form was current equals voltage divided by resistance. Our units are amps, volt for voltage, and ohms for resistance. And we can use this to predict electric current, how much electricity our different devices use. And we're going to do that in the project we're making, the game of operation. So let's see what these electric circuits look like. All right, so the game operation is a pretty simple, straightforward circuit. We have electricity going from our battery into a buzzer and into our LED. And our switch is actually the tweezers that we use. So the question for us is, how much current does our circuit use? And what does that mean for maybe how long our game would last? Stuff like that. Okay, but electric circuits, closed loops, make up the total of all of our electronic devices. We're just controlling the pathways and how much electricity moves at any given time. Okay, question one. Let's do a little bit of practice. What current goes through a person if their skin has 10,000 ohms of resistance and are zapped with 10,000 volts? All right, go ahead and attempt it on your own. If we use the triangle method, we have I equals V divided by R. So we have 10,000 volts divided by 10,000 ohms, and we get 1 amp. That's actually quite a bit of current. Question two. What voltage is required to light a light bulb with 1 amp with a resistance of 10 ohms? Okay, we're trying to find voltage. We cover that up. We see I times R. Go ahead and attempt it on your screen. V equals I times R. We have 1 amp times 10 ohms, and we get 10 volts. Okay, we think to ourselves, batteries we often use are about 5 to 6 volts. Question three. What is the resistance of a toaster that requires 100 volts of electrical pressure to get a current of 10 amps? All right, we cover up R with our thumb. We see we have V over I. So we have 100 volts divided by 10 amps, and we get 10 ohms. Not too bad. Okay, so what's the deal with electric circuits? Well, just like our game of operation, where we saw tiny little dots move around, we have our electrons moving through our circuit from high concentration, the negative terminal, to low concentration. And moving electrons possess electrical energy, which we say is just the kinetic energy possessed by the fact that they're moving. And as we have electricity go through a closed loop, we can run it through different devices, motors, lights, something to any sort of resistive element will give us thermal energy. And we can convert, as we run that electricity through different devices, we can convert electrical energy into other forms. So our computers, motors, cell phones, all they're doing is giving us an energy transformation. Okay, but importantly, where does that energy come from? It comes from our sources of electrical pressure, which for circuits are batteries, capacitors, or our generators and wall plugs. All right, so let's start with a very simple circuit. This is our battery and light bulb. Here we have a battery symbol. You might recognize this in terms of, doesn't it kind of look like that set of plates that we put together to make the voltaic pile? Yeah, it does. Our original battery is preserved as the battery diagram in circuits. Okay, and electrons go from high concentration, the negative terminal of the battery, through our devices and into the positive terminal, from high concentration to low concentration. Okay, in particular, for electrons to flow, we need to make sure that we have closed circuits where there's absolutely no gaps. This is just going to allow our electrons to flow through our conductors. But if you have a gap, then there's not a complete set of conductors for the electrons to flow through. In fact, in between our gap with switches, we have a whole bunch of air, which is a great insulator. So to allow our electrons to go from high concentration to low concentration, we need to have a complete loop, or a circuit. Let's take a quick look at the effect of open versus closed. Great. So as soon as we open the circuit, electrons stop moving because there's no pathway. They would have to force their way through an insulator air, which can be done in the right circumstances, but you need an amazing electrical pressure. So we need to make sure that for us to be able to convert electrical energy into other forms, we need to have closed loops. So a tiny bit of practice. Go ahead and circle the check mark for each of these if the light bulb will light and if these are closed circuits. Okay, you've had a chance to try it, hopefully. Here we have a closed circuit, or an open circuit. This one is certainly closed, certainly closed. This one is closed, closed. Nope, this one is open. Our electrons are going to stay down there. This one is definitely closed. Okay, same thing. give these ones an attempt. Pause the video. All right, this is a closed circuit. These are open. No pathway for electrons to go from high concentration to low concentration. Okay, over here, the light bulb will not light, but we do have a, we're going to say no, because our electrons negatively, or high pressure here is connected to high pressure here. This is not a overall closed circuit for our light bulbs. All right, right here. Yep. Over here, no, same problem. High concentration, provided our batteries are actually the same. There's no reason for electrons to move. They would not have any room to spread out. Okay, not too bad. What if we were to apply Ohm's law to our circuits? Well, this is something we're going to do with our operation game. We're going to predict how much electrical current we have at any point. And this is pretty easy to do once you know the voltages. And this is typically given to you because you know, like, well, I'm plugged into the wall. That has a certain voltage. That's standard amongst all US homes. Or you're using a battery where you know what the voltage is. So to use Ohm's law on circuits, you just go through the steps of, do I know voltage? Do I know the resistance of the materials that my current's going through? If that's true, then yeah, you can find the current. So here's our simple light bulb and battery circuit. We would say that as soon as a wire is connected to the negative terminal of the battery, this entire branch has the same voltage, same electrical pressure as this terminal of the battery. Why? Because electrons want to spread out. Okay, and then over here, the exact same thing. As soon as there's a wire attached to this branch of the battery, the voltage is the same as the terminal of this battery and this branch. Why? Because electrons want to spread out. So we can say we have 6 volts in this entire branch. And down here, we're going to say this is 0 volts. And you're like, Mr. Miller, isn't that kind of backwards? Wouldn't the electrons flow from this side to this side? Yes, but we have our convention from our friend Benjamin Franklin, who said that positives move and negatives don't, and this is how we do it in electrical engineering and in industry. Okay, if I wanted to find current, block this, I see I equals V over R, and what do I get? I get 6 volts divided by 0.7 ohms. Okay, not too bad. Here we have the same thing. Let's let you practice that on your own. Okay, the overall current is going to go this direction. Well, we see we have one pathway, so we have voltage over resistance, and as a result, we have 6 volts over 10 ohms, and we get 0.6 amps. Not too bad. Let's do one last one. This one's a little bit different, but let's start with the same process. Okay, we have 2 overall loops here. We call it a parallel circuit. Electrons can flow this way, and electrons can flow this way. Okay, as soon as our battery is connected to some wires, this entire branch right there has the same voltage as that terminal of the battery. As soon as we're connected to the other terminal of the battery, this entire branch up here is the same voltage. So we start there. This is 6 volts. This is 0 volts. So what is the current flowing through here? Let's call this 1. And what is the current flowing through here? Because the overall current is going to come from our battery, right? Like that. And it's going to break up, and it's going to go into here and into here. So our total current equals the current through 1 plus the current through 2. We'll let you solve that on your own. It's the same method. You should do it for this part and this part, just like you did it up here. Okay, let's read our summary. So we've started to look at circuits. We're going to be using Ohm's law to analyze circuits. The purpose of circuits, as we said, are pathways for electrons to flow from the negative terminal of our voltage source, high concentration, to the positive terminal, low concentration. And they're devices that are intended to convert electrical energy into other forms, using motors, light bulbs, or some resistive element that will heat up. For circuits to function, they have to be closed. It represents a complete pathway for electrons to move from high pressure to low pressure. And then finally, we can use Ohm's law to predict how much electrical current a circuit would use, how much electrical energy we have, and therefore, in more advanced physics, we can predict movement and things like that. All right, good job, guys. We'll see you next time.